All right, so we're going to do some practice on our perfect cubes. And of course, the first thing we do is make sure they're cubes. And p cubed, it's divisible by 3, that exponent, so we know that that's a perfect cube. We always keep the sign, and of course 1000 is 10 times 10 times 10, or 10 cubed. So the cube root of 1000 is 10. And then we go to this new binomial. We square the first. We keep the sign, change the sign. We multiply the two terms. The second sign is always a plus, and then we square the second term. And that's all there is to that. Again, this is a place where you may want to turn the video or pause the video and do them really quick and then come back and see how things went. All right, our next one, the cube root of x cubed is x. We keep the sign. The cube root of 64 is 4. Again, we don't look at that again. We look at our new binomial, square the first, change the sign, multiply the two, always a plus, square the second, and you're done. You can see that once you get used to it and once you get it memorized and you sort of say it as you do it and practice it that way, this becomes pretty straightforward. Our next one, again, remember that we have to look and make sure every single piece is a cube. So 27 is 3 cubed, y cubed, obvious, and 64, again, 4 cubed. So we know that it's perfect cubes. So we take the cube root of 27, the cube root of y, keep the sign, the cube root of 64. We're done with that. And now we just, square the first term, so it's 9y squared, change the sign, multiply the two, always a plus, square the second, and done. All right, one more time with, this time I've got something that's just got variables in it. They're both divisible by 3, the exponent, so we know they're cubes. So we have cube root of x cubed is x, keep the sign, cube root of y cubed is y. Again, done with that. Square the first, change the sign, multiply the two, always a plus, square the second. Same thing here. Let's get a little bit more room for that. So we want to make sure again that everything is a cube. 64 is 4 cubed, 125 is 5 cubed. So we have 4x, keep the sign, 5, square the first, change the sign, multiply the two, always a plus, square the last, and we're done. All right, let's just do a few more. Again, you may want to pause the video and try them on your own. So looking to make sure everything's a cube. So 125 is 5 cubed, 64 is 4 cubed, and these are both divisible by 3. So they are perfect cubes. So this is definitely the difference of cubes. So we take the cube root, keep the sign, cube root, and there's our first little binomial. And now we're just going to work off of our new binomial. So we square the first, change the sign, multiply the two, so 20pq, always a plus on that second sign, and square the second, and you're done. The more you do this, saying those steps, the less you actually have to think about it. Once you've said the steps and done it enough times, you will discover that you don't have to think too hard when you're doing these, but it does take a bit of work to get there. So again, is p to the 6th a perfect cube? And the answer is yes, because it's divisible by 3. 1 is a perfect everything. So the cube root of p to the 6th, remember to find the cube root, all we have to do is divide that exponent by 3. So when we divide the exponent by 3, we know the cube root is p squared. We keep the sign. Cube root of 1 is 1. Again, I'm just going to work off of our new binomial. Square the first, change the sign, multiply the 2. 1 times p squared is p squared. Always a plus. Square the second, and you're done. Again, we look at these. Is 16 a perfect cube? And the answer is no. All right, so now we've got something else we need to think about. 16 is a perfect square, but 54 is not a perfect anything. And this cube tells us a really good clue that there's something interesting going on here. And what we have to remember is that we're always looking for greatest common factor. So every time we go into this, if you see something that doesn't look familiar, you need to look for a greatest common factor, particularly, every time, but on binomials, if you don't find the greatest common factor, you can't do it. So you absolutely need to do this before you can move forward. And we see that 2 goes into both of those. 4 goes into that one, but 4 does not go into 54. So 2 is our greatest common factor. And then I just divide that out. And after we've divided out our greatest common factor, we see all of these things. The 8 is a perfect cube. The t cubed is obviously a perfect cube, and the 27 is a perfect cube. So now we're just going to take it and go further with it, because this is the difference of cubes. So the cube root, keep the sign, cube root. I'm not looking at that again. And now I'm looking at my new binomial. Square the first, change the sign, multiply the 2, always a plus, square the last, and you're done. So again here, the key was finding that GCF first. Now when we look at this next one, we kind of go through the same thing again. 3 is not a perfect square, and it's not a perfect cube. However, 3 does go into 24 evenly, so 3 is a GCF. And when we divide that GCF out, we're left with y to the 9th plus 8. Now 9 is a perfect cube because it's divisible by 3, and 8 is a perfect cube because it's 2 times 2 times 2. So again, we do the same thing. We continue factoring, bring our GCF with. The cube root of y to the 9th is y cubed. We keep that sign. Cube root of 8 is 2. Now, again, y to the 6th, change the sign, multiply the 2, always a plus, square the last, and I'm done. We're going to do just a couple more just because I want you to see things that are a little bit more complex. Mainly, you're probably not going to see much that get this complex in your work, but you will in the next class. And I need you to see that really the process is exactly the same. Now that I'm thinking about it, I may have some of these on your homework, some that are a little bit more complex on your homework. So again, are they perfect cubes or are they perfect squares? It's a binomial. We can see that they're both divisible by 3. They're not both divisible by 2, so they can't be perfect squares. So these are perfect cubes. So the cube root of x to the 12th is, and we divide it by 3 to get x to the 4th. Keep that sign, divide that 15 by 3 to get, the 5. And now we've got our new binomial. And now we just follow that same process. Square the first, change the sign, multiply the 2, always a plus.
Yeah.
Sorry about that. Always a plus, and square the second. So that's y to the 10. And that's done. So let's look at this last one. Again, a few more things going on, but we have to decide. We know it's a binomial, so we basically just have to decide, is it a square? Does it have a GCF? Or are they cubes? So those are our 3 options that we have right now for binomials. So in this case, we see that we have a 6 divisible by 2 and 3, a 3 only divisible by 3. So right there, we know that it's got to be a cube, but we want to make sure everything is. 9 is divisible by 3, 18 is divisible by 3, so this is definitely a perfect cube. So as we do this, we literally just take the cube root of every single piece. So the cube root of x to the 6th is x squared. Y, that one's an easy one, keep the sign. Cube root of p to the 9th, divide that by 3. Cube root of 18, divide 18 by 3. And now we've got our new binomial. And now we're just going to multiply things back. So the cube root of the first term. So the first term is this, x squared y. So the cube root, the square of that is x to the 4th, y squared. Then we change the sign. Then we have to multiply this, and these are big, so we have to multiply these things together. I'm just going to go in alphabetical order. The nice thing when we're multiplying variables together, we really don't have much work to do. And that's it. And then the second sign on this trinomial is always a plus, and then we square the second term. So that would be, let's see, p to the 6th and q to the 12th, and that's it. So it looks a lot worse, but the process, again, if you can just get the process down and keep doing process, not a big deal.